Now we'll discuss about basics of wrapper classes. So wrapper classes allows you to have an object type for all the primitive type. So in Java there are 8 primitive data types are there. So for all the primitive data types we have equivalent classes in Java. So we call those classes are wrapper classes. So we'll discuss it how to create and how to work with wrapper classes in Java. So we'll start with what is a necessity behind the wrapper classes in Java. Then we'll move on to what are all the wrapper classes are there, what is a class hierarchy. Then we'll discuss about the important concept in Java, that is AutoBoxing as well as unboxing. Then finally we'll discuss about clone method of an object class. So for in Java we have 8 primitive data types are there, and for all the primitive data types we have an equivalent object representation, and we call it as wrapper classes. Apart from the wrapper classes concept, we have collection framework in Java. So collection framework allows you to store a collection of object type. So wrapper classes allows you to store primitive values inside of your collection. So that is a idea behind wrapper classes. So in collection type you cannot store a primitive data type directly. So instead storing primitive data types, you can create it as an object and you can store it in collections. So that is the idea behind primitive type. So the process of converting or changing the primitive types into an object type is called wrapping, and that is why these classes are called as wrapper classes. For example, if you want to declare an integer type in Java, this is how we'll declare it: integer I equal to 10, and the corresponding object representation of the same integer variable, you can create it like that: integer I in capital, then the reference name, the new integer of I, right? So here we are wrapping the primitive data type into an object type. So in Java AP we have classes like integer, float, double. So these classes allows you to perform a wrapping of primitive data type into an object type. And moreover, whenever you try to store a primitive type into an object type always require more memory. For example, if you create an integer as a variable, you need 4 bytes, but if you are creating it as an object type, you need 12 to 16 bytes of memory for storing an integer object type. And for retrieving a primitive value from an object type, you can go with an int value method. Suppose if it is a float type, you can go with a float value. And moreover, in wrapper class type we have a lot of predefined methods which allows you to manipulate your primitive data types. So for example, if you have a number which is in string format, for example string str equal to 100, if you want to convert that into an integer type, there is a method parseInt, right? So parseInt method is a part of an integer class, and integer is a wrapper class in Java. So likewise, inside the wrapper class we have other set of methods to manipulate your data. So parseInt of str will allows you to convert a string type of data into an actual number. Apart from the predefined methods of integer or wrapper class, we have a constant like maximum value, minimum value, not a number. So these are all certain predefined constants which are part of integer wrapper class. And this is the hierarchy of wrapper class. So the hierarchy starts with an object. Under object class we have subclasses like number, character and boolean. So character is a wrapper class which is correspond to your character type, and boolean is a wrapper class which is corresponding to your Boolean type. And under number class we have all the number wrapper classes which allows you to store a number. So byte, short, integer, long, float and double are part of number class in Java. So we'll start with an integer class. So if you want to create an object for the integer class, either you can go with by passing argument as a number, or you can pass an argument as a string. So with these two constructors you can create a number. Apart from that, we have methods like parseInt. So parseInt allows you to convert a string type number into an actual number. And there is a method int value. So int value will allows you to convert wrapper to primitive type. And so this is how we'll create an integer wrapper type. So integer I1 equal to new integer of 100. So this is a valid way. Or you can go with new integer of 100. This is also valid method. Apart from that, we have methods like byte value. So byte value, in the sense you will get the byte value of a given number, and double value returns the actual double value, and then float, long, short. So these methods are part of all the number type wrapper classes. For example, these methods are common in long, short, byte, float, double wrapper classes. So here we have an integer I1 with a value of 20, and you suppose you wanted it as a double, you can go with I1 dot double value. So that will return the double value of a given integer. And regarding character class, suppose if you want to create a character wrapper type for the given data, you can go with a character of by passing argument C, and there is a method char value that returns the actual character value. So that is about the character class. And apart from that, we have constants like maximum value, minimum value, then type. So these are all certain constants of a character class. Apart from that, there is a method toString, so that simply gives you the description about your character. Then there is a method toLowercase, which is part of a character class. Suppose if you want to convert a character as a uppercase or lowercase, you can go with two uppercase and two lowercase, and argument should be of a corresponding character you would like to convert. Then for Boolean class, we have a two constructor Boolean of by passing either true or false. Otherwise, you can inside the argument you can pass it as a string. So string should contain either true or false inside double quotes. So that is about Boolean wrapper type. Then for float class, we have two constructor. So inside the argument, either you can pass float as an argument, or you can pass string as an argument. And there is a method value of. So the value of method will try to convert your argument into one string, into one float type. And there is a method float value that converts your wrapper type into one primitive type. And for double class, so we have a constructor like double of by passing a double as a number type, argument type, and you can pass string as an argument type. Apart from that, we have methods like value of, which is similar to that of your float, and double value that tries to convert your wrapper type into one primitive type. And for long, you can create a long object by using these two constructors. Either you can pass a long number as an argument, or you can pass a string as an argument. And there is a method value of that will convert your string type argument into one long type, and long value simply converts your wrapper type into one primitive type. And this is for short class. Short class also we have two constructors, short number, then string str. So these two arguments are converted into one short type, and there is method value of and short value. So the value of method will simply convert the argument string into one short type. And this is for a byte class. So byte, we have two constructors, byte of you can pass byte as an argument, or you can pass a byte value inside a double quotes also. And there is a method value of. So this is for converting string type into one byte type, and byte value that is meant for in returns the actual primitive value of a given object type. And there is something like AutoBoxing and unboxing in Java. So from JDK 1.5, the conversion between the primitive into object type and the corresponding wrapper class, it is it is a part of JDK from 1.5. So it is still possible to convert your primitive into object type and object type into primitive type. So in AutoBoxing, suppose if you are declaring a statement like that in Java, integer I1 equal to 10. So here the 10 is a primitive type. So primitive type will be converted into an object type by default. So this is called as AutoBoxing. Regarding unboxing, so here we have an integer variable, integer I equal to 0 and I equal to new integer of 10, right? So in the left side part, I is a primitive type, and the right side section, it is an object type. So in that case, the object type is converted into one primitive type, and the primitive value is getting stored in integer I. So that is known as unboxing. So from JDK 1.5, the AutoBoxing and unboxing perform the conversion of primitive into object type and object type into primitive type by default. So these are all certain statements where you can find why it is wrong and why it is correct. So in the first statement, you are creating a byte b equal to 12, and you are assigning it to an integer object, right? But b is a type of byte, so you cannot convert a byte type into an integer object directly. And here in the second block, byte b equal to 12, integer I1 equal to integer of b. So here you are performing casting, right? So in casting, you cannot convert another type of object into another type of object. So this is also invalid. So you are trying to convert a byte data into an integer object, so which is still wrong. So here what we are doing here is, first of all, we are trying to convert a byte type into an integer primitive type first. Then you can directly assign it to an integer object. So this is a valid. So what is the output of the given code? So here we have a method m1 which takes integer object as an argument, and we have a main method test. We are creating an object for the class, and we are invoking t1.m1 of 10, right? But 10 is a integer type over here, but the argument is takes object type. What will happen? AutoBoxing will happen. So the 10 will be converted into one object type, and here it will print the value of 10. So here we have two methods, m1. So this is method overloading. So m1 takes double as an argument type, and m1 takes long as an object type argument type, and we have a main method integer x is equal to 0. Test, we are creating object for the test, and we are invoking m1 of x, right? So m1 of x in the sense, so x is an integer type, but there is no equivalent integer type inside your method. But what will happen is m1 of x will directly mapped with a long, because widening will happen. Integer can be widened into one long, but integer type cannot be converted into one double type, because double is a object type. So for this method, yeah, the second method will be get matched, and here we are creating a long object, right? And we are passing it as L1. So there is no there is no long object, but instead long primitive type. So this will invoke long primitive type. So in the given case, in function overloading, widening or narrowing given a most priority rather than boxing and unboxing. So here we have a method with an integer primitive as an argument, integer object as an argument, and byte b equal to 10, function of b, right? So in that case, you are passing byte variable. So byte can be widened into integer type. So in that case, the first method will get match and int will be printed. So what is output of the following code? So we have a class test with the main method. We are starting with x is equal to 0. It is a primitive type. Y is an object type. X w equal to y. So what will happen here? X is already primitive type. Y will be converted into a primitive type and it will be compared. So both x and y contains the value 10. So this is a relational operator. So it will become true. So true will be printed. So which is not the wrapper type. So we have 8 primitive types in Java. So for all the 8 primitive type, we have equivalent wrapper type. And here string is not a wrapper class. String is a class in Java. It is not a wrapper type. And regarding cloneable clone method, so while in the object class in Java, we discussed about a clone method. So clone method allows you to create an exact copy of an already existing object in Java. And if you want to clone an object of a particular class, then your class should implement a special type of interface known as cloneable interface, right? So whenever you make a copy of an object reference, so original and copy are references to the same object. So you are creating a copy for an object, then whenever you try to make changes in an existing object, also affect other object. So the clone method, it is a part of an object class and your class should implement clonable interface. And during cloning, it performs bit by bit copy of an existing object, right? Suppose so clonable we call it as a marker interface which does not have any method. So your class should implement clonable interface. Then only you can able to clone your object. Otherwise, you will get an exception like clone not found exception is thrown. And moreover, whenever you invoke the clone method, it is not going to invoke the constructor for creating object. Instead, it will take the copy of an already existing object. So clone is simply an exact copy of the original object. So far we discussed about the usage of wrapper classes, then what is AutoBoxing and unboxing, then finally we discussed about a clone method in Java.